Number 13. The ratio of dogs to cats at the local animal shelter is 3 to 5. If there are 21 dogs at the shelter, how many cats are there? So we have a ratio of dogs to cats. So here we have dogs to cats, and it's 3 to 5. So we have to keep that in the same order, 3 to 5. And it says if there's 21 dogs, so it goes on, how many cats are there? Well, how many times greater from 3 to 21? It's 7. And you can find that by doing the inverse property of multiplication, which is division. 21 divided by 3 is 7. That's how we found the multiplier. Well, if you have 7 times as many dogs, you're going to have 7 times as many cats. So 5 times 7 is 35. There are 35 cats at the shelter. Number 14. Find the absolute value of each number. Remember, absolute value is the distance from 0. So the absolute value of negative 5 is 5, because negative 5 is 5 units away from 0. The absolute value of 6 is 6. The absolute value of negative 2.5 is 2.5. Number 15. What is the product of 1/2 and 3/4? Well, product is the answer to a multiplication problem. So when you're asked to find the product, you're multiplying the two values. So we have 1/2 multiplied by 3/4. First thing I want to do is to see if I can cross simplify, and I can't. So I'm going to multiply the numerator straight across, 1 multiplied by 3 and 2 multiplied by 4, which we get 3/8. Number 16. What is the reciprocal of 2 and 4/7? Well, first, before we find the reciprocal, we have to take this mixed number and write it as an improper fraction. So in order to do that, you multiply 7 times 2, which is 14, and add the numerator, plus 4 is 18, and you keep the denominator of 7. Now that we have it written as improper fraction, we can take the reciprocal of 18/7. We just flip it, which is 7/18. Number 17. Abby divided 5 2/3 by 9. What number did she get? So we're going to go ahead and divide these two numbers, but first we want to turn this mixed number into an improper fraction. So 3 multiplied by 5 is 15, plus 2 is 17. Keep the denominator. And now we're going to divide this number by 9. And so to divide fractions, you use keep it, change it, flip it, or keep it, change it, and take the reciprocal of the second number. And so I took 17/3 divided by 9/1. I wrote 9 as a ratio. This still has a value of 9. And so keep it, switch it, flip it, and we get 17/3. Change the division to multiplication, and take the reciprocal or flip it. 9/1 becomes 1/9. See if you can cross simplify. You can't. So I multiply straight across. 17 times 1, which is 17. 3 times 9 is 27. Number 18. What is the greatest common factor, or GCF, of 16 and 24? So factors are two numbers when multiplied together equal this value of 16. So I have 1 times 16 is 16. 2 times 8 is 16. 3 doesn't work. If I do, there's not a number I can multiply by 3 to get 16. And then 4 times 4 is 16. And so I just write 4 once, and I'm done. Now to find the factors of 24, 1 times 24, 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24, 5 does not work. So these are common factors but the greatest common factor is 8. Number 19, what is the least common multiple, or LCM, for 3 and 5? So multiples of 3, 3, 6, 9, 12, 15. Multiples of 5, 5, 10, 15. So when I do the multiples for 3 and 5, the first one that they have in common is 15. Number 20, write the numbers in order from greatest to least. I always like to underline or highlight, so I make sure that I write it in the correct order. Sometimes it'll say least to greatest, but this one says greatest to least. So if I look at these values, I know that the greatest values are going to be positive numbers. So at first, I only want to look at the positive values because those are going to be greater than negatives. So, and it's a little easier to deal with just less numbers. And so now I only have to order these 4 numbers instead of all of them from greatest to least. So I'm starting 8.4, 8, then 7, then I go 6, 5, 4, 3. Here's a 3, 3.5, 2, 1, and then 0. Now that I have the positive values in order from greatest to least, now I can deal with the negatives. And remember, for negative values, the greater the negative number, the smaller the value it has. So here's 14 and a half. That's a very large number, but it has a small value because it's negative. So you want to get the values that are closest to 0 for the greatest value. And so that would give us negative 5.3, then negative 14.5, and then negative 15. Negative 15 is the smallest value. It's the negative number that's the farthest from 0. Number 21, we're going to add 1 2/3 plus 3 3/4. To do this, I'm going to start by converting both of these mixed numbers into improper fractions. 3 times 1 is 3, plus 2 is 5. Keep the denominator, so I have 5/3. 4 times 3 is 12, plus 3 is 15. Keep the denominator 4s. Now I'm going to add 5/3 and 15/4, so I rewrote it over here. Before I add these, I need to find a common denominator because I can't add thirds and fourths. So I can find the common denominator by finding the least common multiple. Multiples of 3, 3, 6, 9, 12. Multiples of 4, 4, 8, 12. So the least common multiple is 12. And what did I do to these values to get 12? Well, for 3, I multiplied it by 4. 3 times 4 is 12. And whatever you do to the denominator, you have to do to the numerator. That's why I'm multiplying it by a giant 1 of 4s. 5 times 4 is 20. And for 15/4, I multiply it by a giant 1 of 3s, because whatever you do to the denominator, you have to do to the numerator. 4 times 3 is 12. 15 times 3 is 45. Now that they're both broken up into the same number of units, twelfths, I add the numerators. 20 plus 45 is 65. You keep the denominator, which is twelfths. And I took this improper fraction and divided 65 divided by 12, and I get 5 and 5/12. And I can check to make sure that this is correct. 12 times 5 is 60, plus 5 is 65/12, and it is correct. For 22, I need to circle all the integers. Well, let's review whole, integer, and rational numbers. Whole, think of whole dollar bills. $0 bills, $1 bill, 2, 3, and so forth. Integers are whole dollar bills and their opposites, or whole numbers and their opposite. So I can have $1 bill and I can owe $1 bill. I can't have a fraction. I can't rip a dollar bill in half and try to use that. So whole numbers are whole dollar bills, integers are whole dollar bills, and their opposites, owing dollar bills. And then rational numbers are all whole numbers, integers, and any number that you can write in decimal form or as a fraction. So, because whole numbers can be written as a fraction, for example, 3/1 or 2/1, and integers can be written as a fraction, -1/1 or -2/1. But not all rationals numbers are integers or whole numbers. For example, 52/100 or 1/3. Those are both rational, but not an integer and whole. So integer, integer, integer. These are all integers. This is not. This is a rational number, and this is a rational number. For number 23, we're going to do 4/5 divided by 8/12. So to divide fractions, you do keep it, switch it, flip it. So we have 4/5 divided by 8/12. Keep the 4/5, switch the division to multiplication, and flip or take the reciprocal of 8/12, which becomes 12/8. Here, I can cross simplify because 4 and 8 are both divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. I cannot cross simplify here because there's not a number that will divide evenly both into 5 and 12 other than 1. So now I multiply the numerators. 1 times 12, which is 12. 5 times 2, which is 10. This is an improper fraction. Divide 12 divided by 10, which is 1 2/10. 2/10 will simplify to 1/5. So we get 1 1/5. If you multiplied straight across before cross simplifying, 4 times 12 is 48. 5 times 8 is 40. And this can simplify into 1 1/5.